Okay, we're diving into lesson 1, 2, even and odd functions. So in the previous lesson, we were going over how to identify whether or not a graph, a mapping, a relation, what else was tables, if those were representative of functions. So we learned how to do that. Now we're going to be able to classify whether they're not even or odd functions. So in this little table here, it reads that if the graph of a function f is symmetric with respect to the y-axis, we say that it is an even function. So graphically speaking, if we see symmetry about the y-axis, in other words, the graph on the left side of the y-axis is a mirror image to the right side graph of the y-axis, then you know that there is an even function symmetry. Algebraically, what does that mean? Well, in this function notation, we say that f of negative x equals f of x. And what that just means is that for every negative x value, there will be a y, and for every x value, there will be a y in which both of those y values are the same number, the same sign, everything. They're equal because they're mirror images. Now, if the graph of a function is symmetric with respect to the origin, now we're talking about an odd function. So there is two reflections, so to speak. So if a portion of the graph reflects over the x-axis and then over the y-axis, and it's the same graph, then we are saying it's symmetric with respect to the origin. Now, when we talk about function notation and the algebra behind it, what we're saying is that for every negative x, there's going to be a y, and for every x, there'll be a y, but it will be opposite in sign. So the number will be the same, but opposite in sign. So for instance, the y for negative x could have been a 2, whereas the y for x was going to be a negative 2, okay? So we can kind of remember even as having the same y value. So you can make a note here for yourself, same y value. Here, the y values are equal, but opposite in sign, okay? So that's kind of the easiest way to remember this function notation, okay? So looking at the problem number 1, there are 4 graphs, and before we started this lesson, you were supposed to look at a Desmos activity that helped you practice identifying even and odd function symmetry. And so if you haven't done that Desmos activity, go ahead and go do that and then come back here. So pause the video regardless, because I want you to write out the answers for A, B, C, and D, and then come back to me. Okay, welcome back. So here are the answers you would have put for these 4 graphs. The first one was odd, the second even, the third is neither, and this last one is even. Okay, so what I want you to notice is, notice here for the even functions, here's the y-axis, okay, and about the y-axis, the left side of the graph is going to be the exact mirror image of the right side of the graph, okay, and that's happening as if we thought of this y-axis is a place where we could fold our paper, and if we folded it, this portion of the graph would overlap that portion of the graph. That's what happens with even functions. So notice right here's my y-axis. Again, both of those would overlap one another if we folded our paper down that y-axis. Now when it comes to the odd function is symmetric about the origin. The way to visualize it best is there's 2 reflections, so to speak. So I want you to focus on this piece right here, okay? Let me try that again. I want you to focus on this piece right here. So imagine this piece reflecting over this y-axis, okay? Now if it reflects over the y-axis, it would look something like this, correct? So now imagine this little piece right here reflecting again over the x-axis. In other words, causing it to rotate with respect to the origin. So this piece right here, when it rotates over the x-axis, it will indeed become this right here. Okay, so that's what I mean about odd function. Okay, and of course, with this problem, there wasn't any symmetry whatsoever. All right, so notice this. I want you guys to notice this. So if I picked a point right here and a point right here, and let's pick another point that are mirror images here. So these pairs of points are mirror images of one another. So if I kind of made some tick marks here just to identify the values of these points, okay? So let me actually zoom in here a little bit, okay? Notice that this left point would be -2, 1. This one here would be -1, 2. Now, the mirror images of these points would then be on this side was 1, 2, and on this side was, I know I'm a little off on my tick marks, I guess, but this one's supposed to be 2, 1. So the main reason I wanted you to look at these made up values is that I wanted you to see that every x has a negative x value, okay? But for y values of even functions, notice the y values always matched. They were identical. Notice this y value and this y value matched for the x values that are opposite, okay? So even functions, y values always match, okay? So I'm going to put that again just to reiterate what I'm trying to always, y values always match is what I'm trying to say. Always match. Okay, now if we look at odd functions though, okay, odd functions, let's make up a point again. So let's say this was a point and this was a point, okay, and I'm going to make some tick marks. Okay, so let's label those tick marks. So this top one here is -2, +2, and this one here is +2, -2. So for odd functions, again, yes, the x-axis values, the x-coordinate values, I mean, they will always be opposite. You always have an x positive and negative. But it's the y values that I really want you guys to focus on. The y value here for odd functions, notice they were the same but opposite in sign. They are the same but opposite in sign. Okay, so keep that in mind, because I'm going to have you now take that knowledge and go to the next page at the bottom, number 8. Okay, so you are being given 2 tables. All right, table A, they told us, is going to be an even function, and table B is going to be an odd function. All right, so let's make a note of that. This one is even, and the one on the right is odd. So you need to remember the properties that I just told you about even and odd. Okay, I'm going to put it in pink or red or whatever that color is. Remember, even says that f of x, or f of negative x, it doesn't matter actually which one you do first, f of negative x is going to be the same y value as f of x. Okay, they're going to be the same y value. So for every negative x and positive x, so let's look for negative x and positive x. Well, here's a negative x, and here's a positive x. We know that the y values must be equal. Okay, so take that knowledge and see if you can start filling out that table. Okay, so at this time, you are coming back. Hopefully you paused and are ready to see what the answers are. So we were reminded that for every negative x and x, the y values have to be the same. So that means in filling out this table, if negative 5 is assigned to an 8, 5 has to be also an 8. If negative 4 was assigned to a 6, therefore 4 has to also be assigned to a 6. They have to match, okay? So this 3 needs to match, negative 3 has to match with this 3. So this has to be a 4. And so continue that pattern and make sure, and that 0, 0 obviously is the corner point, for lack of better words, okay? So please notice that you are making sure your values are matching, okay? So negative 5, 8, 5, 8, okay? And so forth. I'll do it again. Here was negative 3, 4, there 3, 4. So they have to match. But for odd functions, things changed up a little bit, because this time, if you plugged in a negative x into your function and got a y value, the y value on the other side, when you plugged in an x, had to be opposite. That's what that minus in front of that meant, okay? So these y values, that y value, and this y value have to be equal and opposite in sign. So with that notation, would you go ahead and fill out this table? So go ahead and pause and then come back to me. Okay, welcome back. So here we go again. This x value, negative 5, is paired with the 5 at the bottom. Let me circle that again. So that negative 5 is paired with this 5 at the bottom. And what do we know about the y values? Well, the y values have to be the same number, but they have to be opposite in sign from each other, because it's odd. O for odd is O for opposite. So if negative 5 is negative 6, positive 5 has to be positive 6. Okay, let's try another one. We have to find what negative 4's output is. To find negative 4's output, we need to go to positive 4. Since it's an odd function, it has to be the opposite, but the matching number of the other one. So negative 3 would be a positive 3 for negative 4. I'm doing the opposite this time. Negative 3 was matched to negative 2, so 3 would be matched to positive 2. 2 is matching to 5, so negative 2 has to be negative 5. I switch the sign. 1 goes to 3, so negative 1 has to map to negative 3. And then again, this is our 0, 0. So notice once again, the y values, 3 for negative 4 was a negative 3. Or the negative 3 for negative 1 was a positive 3 for positive 1. Okay, so they had to be opposite in sign. All right. Okay, so let's now come on up here. We'll go back to the front eventually. So here there are 3 graphs, and you needed to show a portion of the graph of an even function over this interval. So they gave us a portion and they wanted us to draw the other portion, okay? So if this graph A were to be an even function, that means over this x-axis, there has to be a reflection and a mirror image on the other side. So let us draw some points that would help us draw this graph a little bit more correct. Hold on, this is kind of slipping on me. Let me see here. All right, so over here, the 3 would be 3, 0. So this has to be negative 3, 0. This one was 1, 2. Let's see here. It was 1, 2, 3, 4, 5, comma 1, 2, 3, 4. So we're going to go 1, 2, 3, 4, 5, 1, 2, 3, 4. So we need to put it at 4 because the y values are going to stay the same. Okay. So just to make it a point, this right here was 3, comma 0. So this one over here had to be negative 3, comma 0. This one here was 5, comma 4. So this one here had to be negative 5, comma 4. So you see how the y values are staying the same, okay? That's my point. So we kind of just connect those dots and then just reminding you with a highlight that this is the piece that we just drew. So that's an even function for sure. Okay, what would be the even function over here? So this looks like a point would have to go right here. A point would have to go back here. This looks like negative 1, comma 2, almost by 2, like around there. Negative 1, comma 2, yeah, I think that. And this one's like negative 2, comma, let's see, this one right here looks like negative 2, comma 2. So let's go 2, comma positive 2. Okay, so mirror image, let us reflect it over the y-axis. There is our even function. Okay, so each one of those points, the y values stayed the same. Okay, it's like this one was negative 2, comma 2, and then this one was 2, comma 2. The y values stay the same, just like we said even functions would be. Last but not least, you will have, what is that, 2, comma 1, 2, 3, negative 2, comma 3, so 2, comma 3. Let's put a dot right here, and it would go across. And then this one right here would have to reflect. This is, what am I going to count here? So there's 1, 2, 1, 2, 3. So 2, comma negative 3 is the dot. So let's go negative 2, comma 3. So I would put an open circle right here approximately. Does that look right? And I would draw a line right there. And that didn't come out right. Let's try that again. And there we go. So there's that reflected line. Okay. So again, just imagine you doubling this paper, right, folding this paper right there, and this would overlap that, and this would overlap that, or vice versa. Okay. That's mirror image even function. So that's what the even function does. All right. So let us force these same graphs and do the same thing we did upstairs, but this time we are going to convert them into odd functions. Okay. So odd function. So we had this point, let's say this point, right? That point was 0, comma, negative 4. Now, for it to become an odd function, we would have to graph 0, comma, positive 4, because the y value has to switch in sign. So let's go 0, comma 4. I'm going to put that dot up there. Okay. All right, let's do another point. Let's say we did this point right here. If that one is 3, comma 0, then our other point has to be the opposite x. The x always has to switch, and 0 has to switch, but 0 is just a neutral number, so that's not going to change. So negative 3, comma 0 goes there. Let's do this point. That is 1, 2, 3, 4, 5, comma 4. So the opposite value would be negative 5, negative 4. So let's go negative 5, negative 4, and put a dot right there. So now we have those pieces. Let me get one more point here to help with the graphing. Let's try 2. Let me see, what would that be? If I go to 2, this is more like 2.8 negative. Yeah, it looks like negative 2.8. So 2 comma negative 2.8. 2 comma negative 2.8. So that's going to be on this side 2 negative comma, and then 2.8 is going to become positive. So negative 2, 2.8 is about right there. So let us connect those dots. Okay. Not the best drawn graph, but you get the point. Okay. There's our odd function. Okay. All right. Let's try this one. So 0, 0 would stay 0, 0. And then negative 2, comma 2 would become positive 2, comma negative 2. You have to flip it. And then 1, 2, 3, negative 4, 0 becomes 4, 0. And then negative 5, comma negative 4 becomes positive 5, positive 4. So all I'm doing, once again, is just switching the y values. That's all I'm doing. Not doing anything special or anything. All I'm doing is following the rule of flipping the sign. Okay? All right. Let me do that a little less thicker here. So all I'm doing is just flipping the sign. That's the new piece that we graphed. All right. Last but not least, let's look at this point right here in red or hot pink. 1, 2, 3, 4. That's what? Negative 5, comma 3. Negative 5, comma 3. So the opposite symmetry value would be positive 5, comma negative 3. Okay, so 1, 2, 3, 4, 5, negative 3. So we're right here. And then it's a straight line all the way to negative 2, comma 2, negative 2, comma 2. So then this side is going to be a positive 2 and a negative 2. You switch the y value. So positive 2, negative 2. So I need to fill in this dot, and the line is going to be straight across. Then we're going to look at this piece right here. Okay. So that piece tells us, well, again, we have, let's use this value right here. All right, let's use that value. If that value is 1, comma negative 1, the other value is going to be negative 1, comma positive 1. So let's go to negative 1, positive 1. That's about right here. We can choose this same point again where we actually did it with the previous graph. That was 2, comma negative 3. So now we're going to do negative 2, positive 3. So that means I have to draw the line from, let me erase this line, this dot here because it's confusing me. So I'm draw from origin to this line. There we go. That didn't look very good. Let's try that again. It's not willing to cooperate, so I'm going to just do that freehand because it's not doing what I want it to do. Okay, so that's what it'd be there. So doesn't matter the shape of your graph, okay? You can force a graph, a sketch of a portion of a graph, and cause it to become an even or an odd function, okay? Because I want you to notice really clearly here, notice in both top and the bottom, these were the same graphs. This is what was given to us. That was what was given us in both problems. But we were tasked to force it to become an even or an odd function. Okay? All right, last but not least, let's go back to the first page. So the first page over here, we skipped number 2. Okay? We need to decide if these functions are even or odd functions. Okay? So what you're going to do is examine every single term and decide whether or not we need to switch the sign of that term. So what I need you to remember is if you have a, let's switch to a different color. If you have a negative value and you raise it to an odd number exponent, your result is still going to be an odd number. Not the result of your final answer will still retain the negative. It will still hold on to the negative. Okay. Now, if your negative number is raised to an even exponent, okay, that original value will end up having a positive answer. Okay. So with odd number exponents, you do switch the sign. You do switch the sign. Negative means opposite. With even exponents, you do not switch the sign. So what I'm going to have you do is when we are evaluating the f of negative x, I need you to look at those 3 terms separately. Okay? So I was given f of x. We are going to find f of negative x. What happens to the f of x function when we substitute negative x into those 3 terms? If I substitute negative x into 3x4, the term is going to remain the same. It does not retain the negative. Okay? Negative 5x squared. If I substitute negative x, nothing's going to happen. It does not change because a negative x raised to an even power will always be positive. So negative 5x squared stays the same. No change. No switching of signs. Opposite sign means odd. Plus 17 is a constant, so we're going to leave it as is. Okay? So I need you to compare. When you compare, notice that this term and this term stay the same. Notice that this term and this term stay the same. And notice this and this stay the same. There were no changes. They are the identical expression for both f of x and f of negative x. And when they are identical, we are going to call those even functions. Okay. Now, what does a odd function look like? Maybe looking at part C will help us understand even a little bit more. Okay. So let's do part C. Let's go find f of negative x. Now the first term was 12x to the 7th power. That's an odd. So when I plug in negative x, it's going to force that 12x7 to switch signs. So 12x7 becomes opposite 12x7. The next term has a 3 for its exponent, so it forces it to change to an opposite sign. So positive 6 becomes negative 6. Negative 2x to the invisible 1 power. That's an odd number. Okay, it's not 0 because it's invisible. It's a 1. Negative 2x to the first power is odd, so it forces that term to become positive 2x. So all the odd number exponent terms end up switching sign. So notice again, positive 12x7 became negative 12. Positive 6x cubed became negative 6x cubed. Negative 2x became positive 2x. Every single one of them switched signs. They went opposite, okay? Therefore, the final answer for this problem is that this f of x function is indeed an odd function. All the terms were opposite in sign. So how does a neither problem look? Well, if you look at the next one, part C, this gives us an example. There's a mixture. That's how you know neither. So notice this was an even number, so x squared stayed the same. Positive 2x is odd, so it's going to switch. Positive 2 is going to stay the same. So in this case, none of them were the same. This and this were the same. This and this were the same. But these two in the middle were not the same, so that messes it up because this and this is opposite. So you either have all of them opposite or all of them the same. And since that did not happen in this scenario, we're going to say this is a neither scenario. Okay? So this is neither. All right, let's go over here. We have f of x equals 4x cubed minus 7. I'm going to write it over here. So f of negative x would be switch, negative 4x cubed minus 7 stays the same. Well, let's compare. If I compared my 4x cubed to this, that switched. Minus 7 to this, it didn't switch, it stayed the same. So there was a mixture of opposite and same. So this is going to be neither. For this problem, this is a bit different. You have to remember what absolute value is about. The absolute value of negative x is still going to be the absolute value of x. So since this problem here matches this one, no changes were made, this will be even. The absolute value of any value will always be positive. All right. So let's move on to the last one in this number 2. So it's a fraction. When you get the ones with fractions, I want you just to worry about the numerator and denominator separately, okay? I don't know why I use the word worry. There's no reason to worry. Just work out the separate numerator and denominator values. So x squared approach is still even, so it's going to stay x squared. Minus 5 is a constant, so it stays minus 5. So if I just separately looking at this as its own problem, that right now is an even number, an even classification, because the x squared stayed x squared and the negative 5 stayed negative 5. Okay, so for now I want you to imagine that this top one is even. As a matter of fact, maybe I should actually write it. So the numerator right now is even. Let's put e. Okay, now let's look at the denominator value. 2x cubed needs to become negative 2x cubed. And positive x, which is positive x to the first power, needs to become negative x. So now we notice that in this specific denominator, the 2x cubed switch to negative. The positive x switched to negative. So we've got an odd situation happening over here. So what I need you to remember is that when you have a combination of even and odd, I want you to tell me that the end result is odd. any combination of even and odd will always be odd. So E over odd or odd over even, okay? So what does that mean? If you end up with an even, that's a really ugly E, an even in the numerator and then even in the denominator, I want you to classify that rational as even, okay? If you end up with odd over even or odd, so I'm going to put over here O over E, it's always going to be odd, okay? So E over O or O over E will always be odd, always, always odd. Also, if you end up with odd over odd, that also would be odd, okay? Neither occurs is if you see the word neither. So if you end up with a neither over some number, like whether, as long as you have a neither over something or a something over neither, it's just going to be neither, okay? So as soon as you see neither, you're done. There's no reason to even keep going, okay? All right, folks, we are down to the last bit, which basically is just a summary, okay? Number 3, the graphs of an odd function are symmetric about the origin. Would you please, please, please remember this sentence, because I promise you it's going to be on the test, okay? So the question now is, what geometric property characterizes even functions? All right. So again, even functions are going to have symmetry about the y-axis, okay? So symmetry about the y. And don't forget that they have mirror images, okay? They will always have mirror images of one another. So I hope this helps and that now you understand how to classify even and odd functions. Thank you so much for watching.